of spring back or cushion. Remember, it's essential that full stop-to-stop travel is achieved on the underspeed fuel governor before the RPM control lever reaches the end of its mechanical travel. With the propeller governor still secured against the high RPM stop, again start the engine and allow the operating parameters to stabilize. During this engine run, we'll verify the underspeed fuel governor low and high RPM adjustments, and also operationally check the propeller governor high RPM setting.
It's worth noting that the propeller governor RPM setting will be affected by engine oil temperature. Since engine RPM will be slightly higher than normal with cold oil temperature should be allowed to stabilize in the normal operating range prior to performing any propeller governor RPM checks. Before releasing the propeller start lock, here's a helpful hint that can be used to determine the approximate setting of the propeller governor. Since a 2.5% separation must exist between the propeller governor and underspeed fuel governor, the following check prevents governor interference from occurring while checking the propeller governor high setting.
With the power lever still at the flight idle position, advance the RPM control lever to the high RPM position. This sets the underspeed fuel governor to control engine RPM at 96 to 97%. If the propeller governor is close to its required RPM setting, then the beta light will still be on. Now, slowly advance the power lever forward of flight idle. The setting of the propeller governor should be approximately 1 to 2% above the RPM setting at which the beta light goes off. In any case, if this preliminary check indicates that separation is less than a minimum of 2.5%, governor separation should be increased before checking propeller governor high. Retard the power lever to ground idle and establish minimum fuel flow. Then move the RPM lever to its low position. Now, verify that the underspeed fuel governor low setting is within the specified RPM range and record the indicated RPM. Advance the RPM control lever to high and record the underspeed fuel governor high setting. It should be at 96 to 97% RPM. Verify and ensure that both engines are adjusted to the same RPM. Moving on now to check the propeller governor high setting, slowly advance the power lever forward of flight idle. As the power lever is advanced towards maximum, engine RPM should increase to the propeller governor setting. For this example, we'll use 100 to 101% for the specified range. Caution: do not exceed the maximum temperature or torque limits. If RPM is above the specified range, don't exceed the time limitations for engine operation above 100% RPM. Once engine operating parameters have stabilized, record the propeller governor high RPM setting. Retard the power lever to ground idle and move the RPM lever to its low position. After the recommended 3-minute cool-down period, the engine can be shut down. If both engines are operating at precisely the same RPM and the propeller governors are set within the specified range of 100 to 101%, no further adjustments are necessary. However, if a propeller governor high adjustment is required, one complete turn of the adjusting screw changes engine RPM by approximately 1%. Clockwise rotation decreases engine RPM, and counterclockwise rotation increases RPM. With the propeller governor high RPM stop screw correctly set, the next step is to adjust the low RPM stop screw. Before performing this check, the propeller governor arm should be secured against its low RPM stop. Again, start the engine and release the propeller start locks. During this check, the RPM control lever must remain at the low RPM position because if high RPM is selected, interference will occur between the propeller governor and the underspeed fuel governor. Slowly advance the power levers to obtain a power setting that ensures stabilized operation in the propeller governor mode. As before, use caution and observe all engine operating limits. After engine parameters have stabilized, and if the propeller governors are matched within the range of 93.5 to 95.5%, then no further adjustment is necessary. After recording the propeller governor low RPM setting, retard the power lever to ground idle and follow normal shutdown procedures. If the propeller governor low stop adjustment is required, the adjusting screw is turned clockwise to increase RPM or rotated counterclockwise to decrease RPM. Now, with both propeller governor high and low stop screws correctly set, the next operational check and adjustment procedure involves the underspeed fuel governor reset function. If the pilot requires reverse thrust during ground taxi operations with the RPM levers at low, this reset function through a mechanical linkage automatically increases the settings of the underspeed fuel governors. This reset action prevents engine RPM bog down or excessive EGT conditions. With low RPM selected, the underspeed fuel governor controls engine RPM at 65 to 73% depending upon the installation requirement. However, as the power levers are moved from ground idle into reverse, the concentric shaft outer lever contacts screw V. This stop sets the pickup point at which the underspeed governor is reset to a higher RPM. The amount of reset is in direct proportion to the amount of reverse thrust selected. To perform the underspeed fuel governor reset check, verify that screw V is correctly adjusted. First, position the pointers on the pitch control and manual fuel valve to the specified angle. For this example, we'll use 16 to 18 degrees. Confirm that screw V just makes contact with the outer lever. This adjustment establishes the pickup point at which the underspeed fuel governor reset occurs in relation to power lever angle. Remember, underspeed fuel governor reset must be set the same for both engines. Next, start the engines. Place the power levers at ground idle and allow the operating parameters to stabilize. Caution. During the following check, do not allow an overtemperature or bog down condition to occur. If either shows evidence of occurring, immediately return the power levers to ground idle. Now, slowly move the power levers to full reverse while watching the turbine temperature and RPM indications. With the power levers held in full reverse, the underspeed fuel governor reset function, when correctly adjusted, should increase engine RPM to the setting recommended for your installation. For our example, we'll use 90 plus or minus 2.5% RPM. If the reset RPM is within the recommended range and both engines are matched, no further adjustments will be necessary. However, if the reset RPM is not within limits, or if the engines are not matched, re-rigging of the reset function is required. Before shutting down the engine, the following procedure will simplify the process of re-rigging the underspeed fuel governor reset function. First, position the power lever at ground idle. And then advance the RPM lever to the specified RPM setting for underspeed fuel governor reset. Set the friction lock on the RPM lever and shut down the engine. Next, on the fuel control, note and record the underspeed fuel governor protractor reading. This is the required protractor angle necessary to obtain the correct reset RPM. Now, to obtain the correct reset RPM, the length of the underspeed fuel governor rod and its position on the fuel control speed setting lever must be readjusted. If the reset RPM is too low, the length of the speed setting lever must be decreased by moving the serrated plate and rod end closer to the underspeed fuel governor shaft, and the length of the control rod must be increased. By increasing the control rod length, the outer arm is maintained at a 90-degree angle to a line which intersects the centers of the concentric shaft and the speed setting shaft. Conversely, if the reset RPM was too high, the length of the speed setting lever must be increased and the length of the control rod must be decreased. After making these adjustments, verify that the outer arm is positioned at a 90-degree angle. And verify that screw V is still adjusted to contact the outer lever at the correct power lever angle. Now, rotate the manual fuel valve and pitch control clockwise to the full reverse position. And compare the underspeed fuel governor protractor reading to the angle recorded earlier. If the existing angle matches the angle recorded earlier, then the underspeed fuel governor reset RPM should be correct. However, if the angles are not equal, readjust the lever and rod length until these angles match.
After adjusting and verifying the underspeed fuel governor reset function, the next step is to rig the propeller governor to the speed setting lever. This rigging adjustment establishes the pickup point for the propeller governor and also provides the required amount of governor separation.
First, rotate the underspeed fuel governor shaft fully clockwise to its high RPM stop and record the protractor reading in degrees. For this example, we'll use a protractor angle of 42. Now, reconnect the propeller governor control rod to the inner shaft lever on the concentric shaft assembly. Be sure to use the correct spacer washers and torque the nut to the specified value. With the underspeed fuel governor held fully clockwise to its high RPM position, adjust screw X so that both the underspeed fuel governor and the propeller governors are contacting their respective high RPM stop screws.
Now let's perform the propeller governor to underspeed fuel governor separation static rigging check.
This is accomplished by holding the propeller governor against its low RPM stop and rotating the underspeed fuel governor clockwise until screw X contacts the tab on the inner shaft. With the linkage held at this position, note the reading on the underspeed fuel governor protractor. As you remember earlier, with the underspeed fuel governor against its high RPM stop, the angle recorded was 42 degrees. The pickup point for the propeller governor, if governor separation is correct, should occur when the underspeed fuel governor angle is 16 degrees plus or minus 2 degrees less than maximum. which is a protractor reading of 24 to 28 degrees. If this static check, however, indicates that governor separation is incorrect, or if governor separation is not the same for each engine, you'll need to adjust the propeller governor threaded adjusting screw. If the results of this check indicate that propeller governor pickup occurs at a lower than desired underspeed fuel governor protractor angle, this means that governor separation is excessive. To correct excessive governor separation, you'll need to decrease the height of the threaded adjusting screw in the propeller governor arm. Conversely, if governor separation is insufficient, as indicated by a higher than desired underspeed fuel governor protractor angle, you would then increase the height of the threaded adjusting screw. Remember, changing the height of the threaded adjusting screw in the propeller governor arm also changes the angle of the inner shaft lever. Therefore, the 7 to 17 degree angle should be rechecked at this time. If it's not within limits, the propeller governor control rod assembly length should be readjusted to obtain the required lever angle. Now, check and if required, readjust screw X so that both the underspeed fuel governor and the propeller governor contact their respective high RPM stop screws at the same time. Repeat the static check for governor separation and note the underspeed fuel governor protractor angle when propeller governor pickup occurs. If correctly adjusted, it should occur at 16 degrees plus or minus 2 degrees below the underspeed fuel governor maximum stop. Next, position the RPM lever to its minimum position and set the power lever to obtain a 35 to 38 degree angle on both the pitch control and manual fuel valve protractors. Now check and, if required, readjust screw W to contact the spring tab on the concentric shaft. The final step is to readjust the propeller governor high RPM stop screw. Rotating it 3 turns counterclockwise corresponds to approximately 103% engine RPM. Remember earlier, screw X was adjusted to obtain a propeller governor setting of 100% RPM. Therefore, repositioning the propeller governor high stop to 103% will not affect engine RPM. Before we conclude Part 3, let's perform an engine ground run to verify engine rigging and control system adjustments. Following the checklist procedures for your aircraft, start each engine and allow the operating parameters to stabilize. Move both power levers from flight idle to ground idle. And again, allow operating parameters to stabilize. To check the underspeed fuel governor reset function, slowly move both power levers from ground idle to full reverse and verify that reset occurs at the same time and rate for each engine. With both power levers held at full reverse, also ensure that each engine resets to the same RPM setting. Return the power levers to ground idle, establishing a minimum fuel flow condition for each engine. With the RPM levers at low, verify that the underspeed fuel governor low RPM settings are correctly matched. Then select high RPM and verify the underspeed fuel governor high RPM settings. Next, advance the power levers forward of flight idle and verify that propeller governor high is correctly adjusted for each engine. Make sure that both engines are operating at the same RPM. Remember, propeller governor high is being established by screw X on the concentric shaft. Now, with the engine operating at a low power setting, retard both RPM levers toward cruise. With both propeller governors set to 96% RPM, the RPM levers should be matched. If the RPM levers don't match, recheck RPM control system rigging. Pay particular attention to the propeller governor to underspeed fuel governor separation adjustment. Here's a hint that'll help you operationally check the separation. With the engine operating at a low power setting in propeller governing mode, position the RPM lever to obtain a propeller governor setting of 96% and set the friction lock. Now, retard the power lever to ground idle and note the percent of RPM decrease. This RPM change is the amount of separation between the underspeed fuel governor and the propeller governor minimum cruise RPM setting of 96%. The separation must be at least 2.5% and should be the same for both engines. The final operational check is to verify the propeller governor low RPM setting for each engine. With the RPM levers at low, establish stabilized operation in the propeller governing mode by advancing each power lever forward of flight idle. Then verify that engine RPM is correct and that both engines are matched. After the operational checks are completed, shut down both engines using normal procedures. After shutdown, position both RPM levers to high and set the friction lock. With the power levers held in full reverse, check the propeller governor reset function by verifying that the propeller governor arm is contacting the high stop screw, which, as you remember, is set for approximately 103% RPM.
This concludes the three-part series on engine control system rigging and the associated adjustment and test procedures as contained in Chapter 76 of the Engine Maintenance Manual. Remember that Chapter 72 of the Engine Maintenance Manual covers the required adjustment and test procedures for the fuel control unit. These operational tests and adjustments include the overspeed fuel governor, flight idle and maximum power fuel flow, and other adjustments that may be required. After viewing this series and by applying the most recent maintenance manual procedures, you should be able to install, rig, evaluate, and correct control system rigging problems. Once the required adjustments have been successfully performed, the TPE331 power management system should provide accurate and symmetrical engine operation.